Guys, continuation to the problems from the directivity. I'll be continuing the remaining problems. So now we are going to solve the problem like find the directivity for the following intensity patterns. Universal sine pattern u is equal to em sin theta. So as I told you, for the universal pattern, theta is lying between the 0 and pi by 2. And for the bidirectional pattern, it should be 0 to pi, which means theta lies between 0 and pi. And for this one pi is always ranging between 0 and 2 pi. Either it is universal pattern or it is a bidirectional pattern. So now we'll see how to find the directivity of the universal sine pattern u is equal to em sin theta. Next is bidirectional sine squared pattern. This is quite interesting. Guys, try to understand the problems like u is equal to em sin square theta and u is equal to em cos square theta. If you understand these two problems, sometimes they may ask you to show directivity of the antenna D is equal to 2 into n plus 1 for the bidirectional cosine square pattern. Cosine square pattern, bidirectional cos to the power of n theta, which means u is equal to um into cos to the power of n theta. If u is equal to um into cos to the n theta, you are required to prove that directivity D is equal to 2 into n plus 1. Okay, first we will see these three problems. At the end, I will explain you how to show directivity D is equal to 2 into n plus 1 for the intensity u is equal to um into cos to the power of n theta. First one, universal sine pattern, where u is equal to em sin theta. Theta lies between 0 and pi by 2, but the pi ranging from 0 to 2 pi only. There is no difference in the pi value. So first write the expression for the directivity D is equal to um by u naught, and how to find first find the total power radiated. From that we will get um. So total power radiated is W is equal to double integration of an u into d ohms, where u for this particular problem is um into sin theta, and d ohm is the total solid angle, which is nothing but sin theta d pi. So which is nothing but double integration of phi is equal to 0 to 2 pi, theta is equal to 0 to pi by 2 into um into sin square theta d pi. W becomes equal to um into integration of pi is equal to 0 to 2 pi in d pi, and express sin square theta in terms of cos to theta, because we know the formula in the trigonometric geometry that cos to theta is equal to 2 cos square theta minus 1 or 1 minus 2 sin square theta. So from that we can replace sin square theta by 1 minus cos to theta by 2 and integrate with respect to d theta. You will get W is equal to em into 2 pi into pi by 4, which becomes equal to pi square by 2 into em. Call it as equation number 1. And next find the radiation intensity of an isotropic antenna, which is nothing but the maximum radiation intensity which is averaged over the all directions. W is equal to 4 pi into u naught. Call it as equation number 2. Now equating equation 1 and 2, you will get pi square by 2 into um is equal to 4 pi u naught. Then divide both sides by u naught. You will get um by u naught is equal to 8 by pi, which is then 2.54. I hope this is double to that of an previous one problem. I think it is an sin square theta, not cos square theta, right? Cos square theta. So next we'll move on to the next problem. Next is that intensity pattern is um into sin square theta. So for this, find the total power radiated first. That is follow the same formula. W is equal to double integration of u into d ohm. U as um into sin square theta, and d ohm is sin theta d pi. Integrate first d pi with d pi for the limits of integration as 0 and 2 pi. Next find out integration of sin cube theta. As we know from the trigonometric trigonometric rule, sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. From this we can evaluate what is sine cube theta, and later integrate and substitute the limits. You will get 8 pi um by 3. Call it as equation number 1. So next write the power radiated for the isotropic antenna, that is W is equal to 4 pi into u naught. Call it as equation number 2, and equate equation 1 and 2, and you will get um by u naught is equal to 3 by 2, that is nothing but 1.5. 1.5 is the directivity of the bidirectional sine squared pattern. And the next problem is that universal cosine squared pattern, that is u is equal to um into cos square theta. So universal means theta lies between 0 and pi by 2. The method is same, only the difference is the limits of integration for the theta is changed. And substitute and first find the total power radiated. So if you find the total power radiated, you will get W is equal to, so 2 pi um into integration of theta is equal to 0 to pi by 2 cos square theta into sin theta d theta. Let us take cos theta is equal to x and differentiating on both sides, you will get minus sin theta into d theta is equal to dx. When theta is equal to 0, what is the value of x? Theta is equal to 0. Cos 0 is equal to 1. Cos 0 is equal to 1. And theta is equal to pi by 2. Cos pi by 2 is 0. Right. Substitute these values in the integration, and again you are getting like this. And then finally you are getting W is equal to 2 pi um by 3 is the total power radiated. And next find the power radiated for the isotropic antenna. We will get W is equal to 4 pi into u naught. Call it as equation number 2. Equate 1 and 2 or divide 1 by 2. You will get um by u naught is equal to 6. That is the directivity of the cosine square pattern. And finally, so I will explain you how to show the directivity of unidirectional operation is 2 into n plus 1 for an intensity variation of u is equal to um into cos to the power of n theta. So first write the expression of directivity, that is um by u naught. Next find the total power radiated. W is equal to double integration of u into d ohm. You know d ohm is a total solid angle, that is nothing but sin theta d theta d pi, and u is um into cos to the power of n theta. So next find out integration of d pi for the limits 2 pi and 0, you will get 2 pi, and then integrate cos to the power of n theta sin theta d theta, and take um as a constant outside. Let us take cos theta is equal to x and minus sin theta d theta is equal to dx. Theta is equal to 0, x is equal to 1, theta is equal to pi by 2, x is equal to 0. Substitute the limits and find out, you will get W is equal to 2 pi um into x to the power of n plus 1 by n plus 1. And this is for x lies between 0 and 1. So W becomes 2 pi um divided by n plus 1. Because if you substitute x is equal to 1, you will get back the same 1. Therefore W is equal to 2 pi um divided by n plus 1. If u naught is intensity of the isotropic antenna, find the total power radiated for the isotropic antenna. W is equal to 4 pi u naught. You call it as equation number 2. Equating equation 1 and 2, you will get 2 pi um by n plus 1 is equal to 4 pi u naught. Then um by u naught becomes equal to 2 into n plus 1. That is nothing but directivity. So this is the required proof for the intensity u is equal to um into cos to the power of n into theta. So thank you for watching the video. So try to practice all the problems, especially on the problems on the directivity, problems on the Friis transmission formula, and also the problems on the gain. Okay, these are the very important for the examination point of view.